or an idea primarily, and you have to set out on a mission to find out if it's true. So, basically, you gotta learn a lot of stuff about what they already know, like chemistry and physics and biology and biochemistry and medicine and stuff like that. And once you figure out what I know now, I've learned all these things. I'm practically some resemblance of basically the quality of a doctor, minus some mediocre math skills. But basically, I understand the geometrical, energetic world on every level, pretty well normal standards, I think, minus some serious chemical details. But basically, there's a lot that you can do in the world. Like right here, this is all about X-ray diffraction, perimeter crystallography, and Fourier transforms, and how you would measure different biochemical particles. You have to crystallize them, you have to grow crystals onto them, and then run them through a goniometer and X-ray crystallography three-dimensionally with three-dimensional sensors of some sort. Your sensors being cameras or some type of image transducer, which would be normally called a, if I could think of the word, what they call oh darn it, I forgot the word. It's actually called it works like a television screen. I can't remember the word, but anyway, it's out there. Basically, particles hit a screen, and they are sensor electronic camera, and they put patterns on those screens that actually enable you to track certain qualities of the external patterns. So, not only that you can predict quite a few of those patterns and how a light comes out, where it comes out at, and where it hits, you can track all of the light with a principle called Fourier transform. Basically, it predicts all of the light and how it travels through the spaces, and where it comes out at each different spin of an X-ray crystal when it rotates while an X-ray is flowing through it. All the different patterns are signals that relay the quality of how much light, a dosage of light, is traveling in and around the atoms in an X-ray crystal specimen. So, like, that Fourier transform will predict all the spaces, the oscillations, and it's really complicated mathematics. A Fourier transform is extremely complicated, and it has multiple species. Which means that because they don't know what's inside of it, it can vary. And as it varies, it creates a different set of spatial geometries. So, like, as you change those up, you have to match them to where the light hits in three dimensions, or whatever dimensions you want to call it. shortly call it three dimensions, a cube basically, and where they hit is what it tells you. And basic chemistry is right here. How ions work and molecular charges, like copper and aluminum, and what their atomic structure is, and how it ionizes, becomes charged, what kind of energy it has, and how it becomes, in this picture, a battery, like copper and aluminum battery with hydrochloric acid possibly. And here's all the ions and all that. And then, you also have, the molecular reactions going back and forth through the battery, and it is also rechargeable. An aluminum copper ion battery is rechargeable, because you can remove hydrogen with electricity. Hydrogen and hydroxyl. You can remove hydrogen and hydroxyl, and you can also discharge the battery. So, but basically, you also get a little bit of electroplating in a battery like this. So, you're going to, because the plates are two different kinds of atoms, your electroplating is going to cause a little bit of an issue. I'd say aluminum copper battery is probably not the best battery in the world, but it is a battery. So, it might be a good battery, I'm not sure. But it's questionable, but it works. It will work as a battery. And you can see here that copper has a +1 and aluminum has a +3 at the exact dosage of acid. So that's the ratio. That means copper is a negative and that aluminum is a positive. So that's how you get your terminals, is by doing what you call stoichiometry. Stoichiometry is the god of chemistry. He's the Jesus Christ, if you will. And he takes all the pawns and figures them out directly how they operate. And stoichiometry is like, if you know everything about it, it's the core fundamental principle of all chemistry. And I know stoichiometry very well, even quantum physically. So, not extremely quantum physically, but chemically quantum physically, I know stoichiometry. So, this is an example of stoichiometry. And this is an example of a little bit of quantum physics here. Fourier transform is very quantum physical. It's extreme. It is an extreme math equation. So you got some pretty complicated shit here. But you can sit anytime, learn and draw and write notes and keep them to remember who you are. You need to write these things down because they sustain a record in history of who you are and what you know about. It's good to keep a notebook. If you don't like computers and you like to just use computers to read or learn, or cell phones, come up with your own ideas and draw in a notebook. I do it all the time. I've written several things. I write about medicine and diagnoses, and I write about people and how your doctor sucks, and not sure genetically modified cells are going to work, and is an organ pathway group of cells in chemistry can cause a barrage of symptoms and signs. My spine, talked about my spine, X-ray emission variance spectrometer, crystallography. Then we talked about we've got a big grocery list here. Particle physics and the origins of math and what math has taught us since the beginning. And some topics about supercomputers, a regular mass spectrometer, fragment ordering, time of flight mass spectrometer, and or an ion trap mass spectrometer. And basically, I got this, so it's pretty well that simple, and you can work with it and do a lot. You can build things, design electronics. You can do a lot of cool things with just a simple composition college ruled notepad. And that's really all you need to know. For all you assholes out there that don't really care or don't think that other people are interesting, nobody needs you around. So good riddance to you.